Hello students, subscribers, viewers, and future engineers. Here is another problem on on beams, particularly determining the nodal displacements at all points here using the matrix approach and of course Excel, because there are a lot of unknowns. And remember, the calculator is only capable of solving 4 simultaneous equations allowed in the board exams. So using Excel and matrix approach, determine the nodal displacements at A, B, C, D, E, and F directly in mm or radians. EI is constant and is equal to 100,000 kilonewton meter square. So here is the beam. Then at A, the loading is 90 kilonewton meter counterclockwise. In the software, this is treated positive. Imagine BC is fixed-ended. Therefore, the fixed end moment here, which is counterclockwise, is W 24 L square 4 square over 12. So you get 32. On the other side, also 32 by symmetry of BC. Then in C, then the fixed end force, this one is WL over 2. 24 times 4 over 2 is 48 kilonewtons upward. For portion CD, imagine this is fixed since there is no load, therefore fixed in moments as well as fixed in forces, 0. For DE, we have this triangular load and this concentrated load. So this concentrated load will have no fixed in moments because D and E are imagined to be fixed, and these 20 kilonewton loads acts over the fixed end. But it is a load that is downward combined with because at the left it's 0, at the right this value here. But before we solve this value, fixed moment here is W 30 5 square over 30. So 5 square is 25 kilonewton meter counterclockwise as shown. While here W 30 5 square over 20, so 37.5 kilonewton meter clockwise. Then the fixed force here is W summation moment E equals 0. So fixed force DE times 5 plus 37.5 is equal to 25 plus 1/2 of 5 times 30 times 1/3 of 5, or 5/3. So computing for FDE, you will get 22.5 kilonewton. So it's also not shown here, but in your scratch paper, you sum up moments about E. So fixed end force DE times 5 plus 37.5 equals 25 plus 1/2 of 5 times 30 times 5/3. So you get 22.5. Summation versus y equals 0. So this is 52.5, though not necessary because this is support. Then lastly, this part is considered fixed-ended, E and F. So the moment here, counterclockwise, W 30, 1 square over 12, you get 2.5 kilonewton meter, as well as here by symmetry. Then summation forces y equals 0. This fixed end force at F, which is also equal to that, is W times 1 over 2, WL over 2. So 30 times 1, 30 over 2, 15 kilonewton meter. So we now set up the stiffness, global stiffness of each element or segment of the beam AB. So this will be the stiffness, and I hope that there's no need to explain how to generate this global stiffness for a member. The numbering 1, 2, 3, 4, 1, 2, 3, 4. For BC, the length is 4. So for instance, this is 12 times 1 over 4 cube. This is 6 times 1 over 4 square, and so on and so forth. 4 times 1 over 4, so that's why it's 1, then 1/2 of 1. and the rest you should be able to generate this for CD, for DE, and for EF. Now, the loading at A is downward load is 0 and moment is positive 90. So 0, 90. The important numbers would be 1, 2, 4 at B because the U3 is 0. Then 5, 6, unknown delta C and theta C. 7, 8, unknown delta D and theta D. Then 10, U9 is 0, U10 unknown. Then here, U11 and U12 as unknowns. So that's why for 1, 1 we have 0, then 90. At 4, we simply have opposite of 32, which is 32 uh, clockwise, and clockwise moment is negative. At C, opposite of 48, 48 downward, so negative 48. Then opposite of 32, counterclockwise 32, so positive 32 at C, corresponding to U6 or 0.6. Then at D, we have 22.5 upward. Opposite of that is 22.5 downward. 22.5 downward plus 20, because there is already a load of 20, that makes it negative 42.5. Then for the moment, it is opposite of 25, so negative 25 or 25 clockwise. At E, 37.5 minus 2.5 is positive 35 because the net fixed end moment is 35 clockwise, so the load is opposite to that, 35 counterclockwise or positive 35. And finally at F, opposite of 15 is negative 15, so imagine we have 15 kilonewtons downward here, and the couple opposite of 2.5 clockwise is counterclockwise 2.5, so positive 2.5. Then we have 1, 1, 1.5, 1, 1, 1, 2, 1.5, 1, 4, 1.5. Then there's no 1, 5, 1, 6 up to 112, so 0, 0, 0, so copy 1.5, 1.50, everything here by symmetry. 2, 2, 2, 2, we have 2 here, and that's the only 2, 2. So 2, 2, 4, 2, 4 is 1, so 1. There's no 2, 5 up 2, 6, 2, 7, 2, 8, and we copy 1 here, then copy everything here. Then 4, 4, 4, 4 is 2 plus 1, so that's why it's 3 here. 4, 5, 4, 5, negative 3/8, and that's the only value, negative 3/8. Then 4, 6, 4, 6, 1 half, so 1 half. Then there's no 4, 7, 4, 8, 4, 10, 4, 11, 4, 12, so copy negative 3/8, 1 half, then 0 everything here by symmetry. Then the rest of the cells you just verify, because I want to shorten the lecture and sample problem video, and you just verify this as your exercise. Then after that, we can now compute these displacements as the product using your Excel there. You just input these values as well as here. These displacements are equal to the inverse of this 10 by 10 matrix, 2, 4, 6, 8, 10. And so this is the product of the inverse of this 10 by 10 matrix using Excel and this force or global forces matrix. Sorry, this one, global forces matrix. And the results would be using Excel. This is in Excel. Then press shift enter, control shift enter, and you'll get these displacements. U1 corresponds to delta A, U2 theta A, U4 theta B, U5 delta C, U6 theta C, U7 delta D, U8 theta D, U10 theta E, U11 delta F, U12 theta F. We get these values here since EI is 100,000 kilonewton meter square, and we have to express the results in terms of mm or radians, so corresponding values in mm and the rest unitless radians. Then from the software RISA to check, we have at node 1, which is at A, there's no horizontal displacement U, but we have vertical displacement of 9.112 mm, which checks. Then the rotation negative 3.656 times 10 to the negative 3, which checks. At node 6, which is F, delta Y or U11 is 6.604 mm, which checks. And theta F is 6.592 times 10 to the negative 3, which also checks. This is in radians. So that's it for this video. I hope that you were able to follow and understand the explanations, and your exercise would be to check these values.